For topic 3, we're going to determine if an ordered pair is a solution to, that should say to an equation in two variables. Excuse the typo. So determine if an ordered pair is a solution to an equation in two variables. Okay. So again, we have some definitions and some things we need to work through. I don't want to go too deep into this and like over explain it, but I want you to have an idea of what's going on. Okay. So let me go back to my yellow highlighter. We have here an equation in two variables is a way to model a relationship between two quantities. Okay, so an equation in two variables, again, it's a way to model a relationship between two variables. Okay, we have lots and lots and lots, like oodles and oodles of equations in two variables. Please do know that your equations are going to have x's and y's in them, okay? I would give you like a generic, but there's not really a good generic equation because it kind of depends. Are we looking at quadratic equations? Are we looking at linear equations? Are we looking at absolute value equations? Are we looking at square root equations, okay? So there's not like one generic equation that I could list. Just know that the variables that we're going to be looking at are x and y. So we're going to look at some relationship that exists between two quantities, and we're going to call them x and y here, okay? Now, a solution of an equation in two variables, x and y, is an ordered pair of real numbers such that when the x coordinate is substituted in for x and the y coordinate is substituted in for y, we get a true statement, okay? So the solution of an equation in two variables, I'm going to go ahead and highlight the x and y. Again, it's an ordered pair that ultimately satisfies the equation. That means when you take the x and the y coordinates and plug them in for x and y respectively, you would get a true statement, okay? Now, here's the thing that's a little bit tricky. When you're dealing with the graph of an equation in two variables, okay, it is the set of all points whose coordinates satisfy the equation, okay? So when we talk about the graph of an equation in two variables, it represents all possible solutions, okay? So that's kind of a little bit tricky. So the graph is a visual representation of all possible solutions. Okay, so that's another thing we have to think about. When we're dealing with equations in two variables, there are infinitely many ordered pair solutions. So infinitely many, excuse me, I had a hiccup, ordered pair solutions. Okay, this is a little bit different than what we did back in chapter 6. In chapter 6, we were looking for just the equation, we were looking for the solution to an equation in just one variable. Okay, so we could just list, hey, this is the solution. Okay, so if we had some linear equation, we could say, hey, this is true when x is this one number. When you're dealing with equations in two variables, you're looking at all possible relationships between x and y that satisfy that equation. So we can't list every single solution. We cannot possibly list every single ordered pair that satisfies the equation. So we use the graph just to represent, hey, this is what the equation looks like. Therefore, this is what the solution set looks like. It's all of the ordered pairs that make up this graph. Okay. So again, it's all of the ordered pairs whose coordinates satisfy the equation. Okay. It's kind of a trippy idea. Hopefully this will make more sense as we progress through this chapter. Okay. So for example 4, it says determine whether each ordered pair is a solution. Notice it doesn't say is the solution. It just says is a solution to the following equation. Okay, so we have 3x plus 5y is 15, and we first want to check to see if the ordered pair -5, 6 is a solution to this equation. Okay, so that means if we plug in -5 for x and 6 for y, we're looking for a true statement. We're looking for the left to truly equal the right. If we get a true statement, then we would say, yeah, that ordered pair is part of the solution set. Okay, so we have the equation 3x plus 5y is 15. Anywhere we see an x, we're going to replace it with a -5. Remember, the first point in an ordered pair is your x. The second point is your y coordinate. So we would get 3 times x, which is -5, plus 5 times y, which is 6. And we want to see, does this really equal 15? Well, 3 times -5 is -15. 5 times 6 is 30. So what is -15 plus 30? Well, it just so happens negative 15 plus 30 is 15. So 15 really does equal 15. So we could say that negative 5 comma 6 satisfies the equation, which means yes, it is a solution. Okay, this would be the technical answer to this question. They're just asking, is it or is it not part of the solution set? In this case, yes, it is. All right, now let's repeat the process. We have the same equation, but this time we want to check to see if the ordered pair 0, 5 is part of the solution set. So we have 3x plus 5y equals 15. Anywhere we see an x, we want to replace it with a 0. Anywhere we see a y, we want to replace it with a 5. So I have 3 times 0 plus 5 times 5 equals 15. Well, 3 times 0 is 0. 5 times 5 is 25. And 0 plus 25 is 25. And unfortunately, that does not equal 15. So we would say 0, 5 does not satisfy the equation. That means it's some point that doesn't live on the graph. Okay, so you have the points that make up your graph. In this case, this is a line. So this would be some ordered pair that's just not on the line. So we would say, no, this is not a solution. Okay, now just for fun, let's scoot over to Desmos really quick. So let me share my screen. But we want to go to desmos.com. So if you are not familiar, Desmos is a free graphing utility. So it's kind of like an online graphing calculator. So when you go to Desmos, DESMOS.com, you pull up the website and then you just go here to open graphing calculator. And when you do that, you can type in your equation. So I want to type in 3x plus 5y equals 15. Type it just like you saw it. So 3x plus 5y equals 15. So this red line represents the equation, okay? Now we tested negative 5, 6 to begin with. So we were right here. All right, well, let me do this. Okay, well, I don't want to do that. Yeah, that'll work. All right, so when we were at negative 5, notice we go to the left 5 and we go up 6, and we are exactly on the line. And that was that first ordered pair that we said, hey, this really is a solution to the equation. Now, the second ordered pair was 0, 5. Let me see. Let me go back to the equation. Was it 0, 5 or 0, 6 or something? Okay, so 0, 5. So let's go back here to Desmos. Okay, so when we go 0, 5, that would be right here. Let me see if it'll let me plot a point. All right, so in blue, hopefully you can see this point here at 0, 5. You can see this point is not on the graph. So that would indicate that it's not part of the solution set. All right, let's plot, what was it, negative 5 comma 6. So in green right here, you can see that that first point really was on the graph. So when we're talking about the solutions to an equation in two variables, it's the points that physically create the graph, okay? If you have a point that is not on the graph, it's a wonderful ordered pair. It's just not part of the solution set, okay? All right, so let's go back to the worksheet. And for example 5, we're going to go a little bit further here, okay? So in example 5, it says create an ordered pair solution for each set of criteria. So in this case, you're given an equation in two variables, and you're given part of an ordered pair. Your job is to complete the ordered pair so that you truly have an ordered pair solution, okay? So for part A, we have y equals 4 minus x squared. And it says here, let x equal 4. So what they're saying is create an ordered pair where x is equal to 4, but we have to figure out the y that's going to make this work. Okay, we have to find the exact value for y that's going to make this an ordered pair solution. So how in the world would we do that? Well, up here, for example 4, we were checking to see if an ordered pair was a solution. So we plugged in the x coordinate for x, the y coordinate for y, and we looked to see if we got a true statement. Well, down here, we only have a potential x coordinate. So plug that in for x and then solve for y. So I'm going to take my equation okay? I'm going to figure out what y is, but I'm going to replace x with 4, okay? So anywhere I see an x, I'm going to plug in a 4, all right? So I have y equals 4 minus x squared, which is really y equals 4 minus 4 squared. So I get y equals 4 minus, well, 4 squared is 16. So I get y equals 4 minus 16. And all I would have to do is simplify. And then I have the very specific y coordinate that's going to match up with that very specific x coordinate to become an ordered pair solution. So y would have to equal negative 12. Okay, so let's go back to Desmos. Okay, so we're going to go back to Desmos. We're going to type in y equals 4 minus x squared. And then we're going to type in the ordered pair for negative 12 and make sure it shows up on our graph. Okay, so I know this is making our video a little bit longer, but I think it's worthwhile. Okay, so we're going to type in y equals 4 minus x squared. So you can just type in an x and then shift 6. It'll do the caret button and then type in a 2. There's also, if you go down here, there's like a little keyboard that you can use it'll let you type in some of those weird symbols that you need. All right, so we have y equals 4 minus x squared. So this is our graph. Okay, this is, believe it or not, the graph of a quadratic equation. All right. Now we want to type in the ordered pair 4 comma negative 12. We want to make sure that really is a point on our graph. And then we're going to have to scroll down a little bit. All right, so notice here, this is our graph. At the origin, if we were to go to the right 1, 2, 3, 4, and then down 5, 10, 11, 12, sure enough, when x equals 4, y has to equal exactly negative 12 in order to be an ordered pair solution for this equation. All right? So let's go back, and don't use this to cheat. Lord have mercy. This is just to give you a good visual representation of what is going on. I still want to see your work by hand, okay? So let's go back to the worksheet and do part B. Now, part B is a little bit weird. Some of you have forgotten all about what part B is asking. So in math, we have something called absolute value. Absolute value represents a number's distance from zero. So if I had the absolute value of 10, that would just equal 10 because I would be 10 units away from zero. If I had the absolute value of negative 50, the answer would just be 50 because negative 50 is 50 units away from zero, okay? So when you're dealing with absolute value, keep that definition in mind, okay? And you know you're dealing with absolute value when you just have vertical bars, okay? So vertical bars around a number or an expression, okay? So the same thing, we want to create an ordered pair. We know that we want x to be negative 2. What in the world would y have to be so that we can create an ordered pair solution to the equation y equals the absolute value of 3x minus 2, okay? So we're going to take the equation y equals 3x minus 2. Anywhere we see an x, we're going to plug in a negative 2, okay? So inside the absolute value bars, we have 3 times negative 2 minus 2. We need to follow the order of operations. So 3 times negative 2 is negative 6. And then negative 6 minus 2 is negative 8. And then we want to evaluate. What is the absolute value of negative 8? Well, negative 8 is 8 units from 0. So we would just say 8. So we now have the ordered pair 2 or negative 2 comma 8. So let's do the same thing. Even though this is taking a little bit of time, I want you to really understand what's happening. Let's go back to Desmos. We're going to graph our equation, and then we're going to make sure the point negative 2, 8 is on the graph. Okay? Desmos. All right, so we had y equals, and let me see if I've got bars here because I don't remember right off. Okay, so when you open up the keyboard, all right, right above the ABC button, you see vertical lines around A. That's absolute value. And then we want to type in 3x minus 2. And do we have to end the absolute value? Yeah. All right, so we've got our absolute value here. And then we want to check the ordered pair -2, comma 8. We want to make sure that is a point on our graph. All right. So let's see what we have here. All right, so this is your graph. I will tell you absolute value graphs look like a V, like with a very distinct point down here. All right, so we want to know, is the point -2, 8 on the graph? And it sure is. You can see from the origin, if I go to the left 2, I would have to go up 5, 6, 7, 8 to be on the actual graph. So when x is -2, y has to be +8 in order to be part of the solution set for the equation y equals the absolute value of 3x minus 2. Okay? So be prepared to do both, be able to take an equation and check an ordered pair, or be able to take an equation with a condition on the ordered pair, like one of the two coordinates, be able to find the other coordinate so that you are for sure getting an equation, or you're for sure getting a solution to the equation. All right. So next up, we're going to look at the point plotting method for graphing. All right. So now that we kind of understand what an equation in two variables is, next we're going to learn how to graph them by hand.